Hello students, welcome to Eshwari Thaniksha channel. In this video, we are going to learn a very important topic, that is spherical mirror from the chapter light, reflection and refraction. So first, let us see what are the two types of mirror which you know. So mirror is of two types. Mirror is of two types. The first type which you have already studied is plane mirror. So plane mirror is the first type of mirror, and second type of mirror is called as spherical mirror. Spherical mirror. So now what is the difference between this plane mirror and spherical mirror? How do they look like? So here plane mirror, you can see it will be having a flat surface. So here this surface will be flat. So this is called as plane mirror. Whereas in spherical mirror, you can see it will be in the form of a sphere like this, curve. If it is in the form of a curve like this, then it is called as spherical mirror. So this is the difference in the appearance. So in this video, we are going to see in detail about this spherical mirror. So what is spherical mirror? What are the types of spherical mirror? And what are the components of spherical mirror? We are going to learn in this video. And about the plane mirror, we have already studied in the last class. What is plane mirror and what are the properties of plane mirror? We have studied in the last class. So students, if you have not watched that video, go to the playlist and you can watch that video. And students, if you are new to our channel, subscribe our channel and also share this video with your friends. So now let us start. So first let us take spherical mirror. Spherical mirror. So now the first question which comes in our mind is from where we can get this spherical mirror, whether it is available underground. So if you dig the ground, whether you will get spherical mirror like that of the gold. So gold, you know that it is available underneath. So same way, whether spherical mirror is also available. The answer is no. Then how do we get the spherical mirror? So how do we get the spherical mirror is, for this you have to take a spherical glass. So this is a spherical glass. So now you have to cut a thin layer of spherical glass. From here you have to cut a small thin layer, you have to cut and separate it out. So that is called as, you will get a glass like this, thin glass like this you will get. So whether this is called as a mirror? No, even this is not called as a mirror. Then how to get a mirror is, you have to coat on one side of the glass with the silver coating, you have to coat. So this is called as silver coating. Silver coating. So on one side, so you can see this is inside and this is outside the glass. On one side we are going to give a coating like this. So what coating we are going to do is silver coating. So silver metal you have to take and give a coating. So now this is called as mirror. So this we call it as spherical mirror. Spherical mirror. So now how we know how we are going to get the spherical mirror. That is, we are going to take a glass, we are going to take a thin layer from that, we are going to separate it out, and then a silver coating we are going to give on one side. Then that is called as the spherical mirror. So now we will see the types of spherical mirror. So spherical mirror types. Spherical mirror. So types, if you see, there are two types of spherical mirror. So what are they? So types of spherical mirror, if you see, the first type is called as concave mirror. Concave mirror. And second type is called as convex mirror. Convex mirror. So now what is this concave mirror? So concave mirror is nothing but you have taken a sphere like this, a spherical mirror like this. So you have to give silver coating. Suppose if silver coating is given on this side, so this side we are going to give silver coating. Then the inner side, so this inside we call it as reflecting surface of the spherical mirror. So this side is called as reflecting surface. Reflecting surface of the spherical mirror. So here, if the reflecting surface is curved inward, then it is called as concave mirror. Let us see convex mirror. So this is the convex mirror where silver coating you can see here. The silver coating will be given on this side. And which is the reflecting surface? This side is called as reflecting surface. Reflecting surface. So if the reflecting surface is curved outward, can you see the curve is outside? If it is curved outward, then it is called as convex mirror. So this is the difference. Concave means reflecting surface will be curved inside, and convex meaning is reflecting surface will be curved outside. Then it is called as convex mirror. So this is the difference between concave mirror and a convex mirror. Next we are going to see very important topic under this, which is called as components of spherical mirror. Components of spherical mirror. So this can be asked in your examination. Definition can be asked, or these components are very important in drawing the ray diagram. So ray diagram is very important, which can come in your final examination. At least one ray diagram will come in your final examination. One ray diagram. So to draw the ray diagram, the basics is this: components of spherical mirror. So if you don't know the components, it is not possible for us to draw the ray diagram. So therefore this is very important. So I'll teach you in a simplest method. You can understand the concept easily, so no need to worry. So usually students will be face very difficulty in drawing the ray diagram. So your difficulty will be solved now. So easily you can understand all the components. We will take one by one and we will see the components. So the first component is called as pole. So pole is represented by capital P like this. So if you see capital P, meaning is it is called as the pole. So what is pole? Pole is called as the center of reflecting surface. Reflecting surface of spherical mirror. Spherical mirror. So this is the definition you will write if it is asked. What is pole? It is the center of reflecting surface of the spherical mirror. Meaning is this is the spherical mirror, and we are going to give silver coating. You can give on this side a silver coating. And which is the reflecting surface now? This is called as the reflecting surface. Inner surface is called as reflecting surface. So the center of that reflecting surface. So this is the center. The center of that reflecting surface is called as the pole. So we will be representing like this P. So is that clear? What is pole? The center of the reflecting surface is called as the pole. This is the first component. So now we'll go for the second component. So the second component is called as center of curvature. Center of curvature. Center of curvature is represented by capital C. So if you see capital C, the meaning is it is called as center of curvature. So now what is the center of curvature is? Suppose if you take a sphere. So this is called as a sphere. So the center of the sphere, this is called as center of sphere. So here I'll write this as center of sphere. But what we have written here, center of curvature. We have not written center of sphere. We have written center of curvature. So to get center of curvature, what we are going to do is, of this sphere, we are going to take a part of this. So a thin part we are going to cut and we are going to separate out. So now this is the spherical mirror what we have cut and separated out, and this center. So this center is nothing but this one. So we have taken this center and then we have taken only a part. So this is called as curvature now. Since we have removed a part from the sphere, so this part is called as curvature. So now this center we call it as center of curvature. So this is called as C, which is nothing but center of curvature. Center of curvature. Is that clear? So what definition we are going to write now? We are going to write it is the center of sphere of which a reflecting surface of spherical mirror forms a part. So understand this step by step what we have written. What is center of curvature? It is the center of the sphere, correct? So this is the sphere. This center what we call it as center of curvature, of which reflecting surface of the spherical mirror forms a part. So here this is the spherical mirror. It is a part of the sphere. From where we have got this mirror? We have got from here. It is a part of the sphere. So therefore the definition is it is the center of the sphere of which reflecting surface forms a part of the sphere. So is that clear? This is called as center of curvature. So next component we will see. Third component, radius of curvature. Radius of curvature. So radius of curvature is represented by capital R. So now what is this radius of curvature? Let us see the definition. Radius of curvature is nothing but it is the radius of sphere. Radius of sphere of which reflecting surface of spherical mirror forms a part. So very simple. So meaning is we are going to take a spherical mirror. So this is the spherical mirror and the radius from the center, this is called as C, center of sphere. So this line, so from center to the pole, so here this is the pole now. This is pole and this is center. So this yellow color line what I have drawn, that is the radius of the sphere, that is from C to P. So this is called as the radius of curvature. That is the radius from the center of the sphere to the reflecting surface of the mirror. This entire length we call it as radius of curvature. We are not using here radius of sphere. We are not using here radius of sphere. Why? Because we are not taking sphere. Sphere means complete circle should be there. I have taken curvature here. Therefore, we have to show only the curve. This curve is nothing but the spherical mirror. Now is that clear? So the radius of curvature is nothing but the radius from the center to the curve is called as radius of curvature and it is represented by R. So I hope it is clear now. So now this entire length we call it as R, that is radius of curvature. Next we will go for the fourth component. The fourth component is called as principal axis. Principal axis. So principal axis, what is principal axis is? This is very simple. So now for this you have to take a spherical mirror. So I'll take a spherical mirror like this and here I have given the silver coating like this. So now Where is the center of curvature? See, this is called as center of curvature. So now I'll draw a imaginary line. And where is the pole present? Pole is present at the center of the reflecting surface. So this is pole. So now if I draw a imaginary line passing through the center of curvature and the pole. So this is the line, imaginary line I have drawn, which is passing through center of curvature and the pole. So this imaginary line is called as principal axis. Is that clear? So what is principal axis? It is the imaginary line which passes through the center of curvature and the principal and the pole is called as principal axis. So definition, what you will write now? Here you will write it as imaginary line passing through. So which are the 2 points through which it is passing? It is passing through pole and center of curvature. So center of curvature. So this is called as principal axis. Now we will go for the fifth component. So here the fifth component is nothing but principal focus. Principal focus. So principal focus, it is represented by capital F. So capital F is called as principal focus. So what is principal focus is? Here we are going to draw a spherical mirror. So this is the spherical mirror I have taken. Let us draw the principal axis. So this is the principal axis. On the principal axis, what you can see? You can see center of curvature will be there and pole will be present. So now draw the light rays. So this is one light ray I'll draw, and this is the second light ray I'm going to draw. So after it falls on the reflecting surface, so this is the light ray which is passing and it is falling on the reflecting surface. After falling on the reflecting surface, it will get reflected back. So that is, it is going to bounce back like this. It will bounce back like this. And this ray which is hitting the reflecting surface will also bounce back like this. So now here you can see this will reflect here like this, and this ray is going to reflect here like this. So this point, so this is the point where both the rays are meeting or intersecting. So the meeting point or the intersecting point is called as principal focus. So this point I'll be writing it as principal focus. Is that clear? So what is principal focus? Whenever light ray falls on the reflecting surface, it will bounce back like this, and they are going to meet at a point, they are going to intersect at a point. So that intersecting point is called as principal focus, and it is represented by capital F. So this is for the concave mirror. For the concave mirror, the focus will be always in front of the reflecting surface. So let us see for the convex mirror where it will be formed. So now let me take, this is the convex mirror. So for the convex mirror, this is the silver coating we are going to give. So draw the principal axis. So we are going to draw the principal axis. So here we have to extend it like this. So this is the principal axis. So here this is called as center of curvature, and this point is called as the pole. So now draw the light rays. So this is one light ray I'll draw, first one, and this is the second light ray we are going to draw. So here after bouncing back, they are going to bounce back like this, reflecting rays. So here it is going to go like this. They are not going to meet on the principal axis. So this is the principal axis. On the principal axis, so here you can see this is the principal axis. On the principal axis, you can see the focus is present. Whereas here, these rays are not meeting on the principal axis. Instead of that, they are diverging like this. They are going away like this. So now what we have to do is, we have to extend this line. So this reflected ray, we are going to extend backward like this. So extend it like this. Now they are going to meet at this point. So this point they are going to meet. So now this point is called as principal focus. Can you see here? We are joining this line at a point. So they are intersecting at this point. So this is called as principal focus now. So where the principal focus is formed, it is formed on the other side of the reflecting surface. This is the reflecting surface. So it is not formed in front of the reflecting surface. Instead of that, it is formed back side of the reflecting surface. So this is the difference between concave mirror and the convex mirror. So this is concave mirror, and this is the convex mirror. So this is usually asked in the examination, where the principal focus is formed in the concave mirror and convex mirror. So in the concave mirror, you can see principal focus is formed in front of the mirror, in front of the reflecting surface. Whereas in the convex mirror, it is formed behind the mirror or behind the reflecting surface. You can see the principal focus is formed. So is that clear? What is principal focus? Next we will go for the next component. So sixth component, this is called as focal length. And it is represented by small f. Capital F means what? See here. Capital F meaning is principal focus. Small f meaning is focal length. So we will see now what is this focal length. So focal length is nothing but, so now we will draw a spherical mirror again. So this is the spherical mirror. Draw the principal axis. So this is the imaginary line, principal axis we are going to draw. So here, this is the silver coating we are going to give. And this is the center of curvature. And this point is the pole. And here you will have principal focus. So what is focal length is? It is the distance from the focal length, from the principal focus to up to the pole. So here, from here to here, this distance. So this is the principal focus and this is the pole. So the distance from here to here, can you see this distance? So this distance from F to P. So this distance is called as the focal length. So what is the definition you are going to write? So the definition what we are going to write here is, you are going to write a distance between it is the distance between the pole and principal focus. Principal focus is called as focal length. So here we have one formula. So what is that formula which is very important for the calculation of the numerical? That is, we will write R is equal to 2F. So what is R here? So R is called as radius of curvature, which we have already studied now, radius of curvature. And F is called as focal length. So meaning here is, where is R in this ray diagram? So here you can see R is here, the distance from here. So from here to here, this distance is called as radius of curvature. So R is equal to 2F, meaning is half of the radius of curvature. So meaning is, once again I'll draw, see here. So this is the spherical mirror what we are going to take. So this is the spherical mirror we have drawn. So now we are going to draw principal axis, and where is the radius of curvature? So radius of curvature is distance from here to here. So this distance is called as R, radius of curvature. So half of this distance you have to take. So half of this distance means till here. So this half of the distance we call it as, so half means till here. That is from here to here. So this half of the distance we call it as a focal length. Is that clear? Focal length is half of the radius of curvature. So from here to here it is radius of curvature. So here this is the center of curvature, C. So center of curvature we have taken from that point to the pole. So till here we call it as radius of curvature. Take half of that. So half of that distance what we have taken is the focal length. That is from here to the pole. This distance we call it as focal length. Is that clear? So remember this formula. So we will be using this in the numerical. Next we are going for the next component, which is the last one. So next, seventh component is aperture. So aperture. So this is very simple definition. So the definition what you will be writing is the diameter of the reflecting surface of spherical mirror. Spherical mirror is called as aperture. Meaning is this is the spherical mirror what we have taken. So the diameter meaning is from here to here the distance. So the diameter of this reflecting surface of the spherical mirror we call it as aperture. So now this distance, so that is from here to here diameter. So this diameter is called as aperture. Is that clear? Aperture is nothing but the diameter of the spherical mirror. So turn this spherical mirror to the front. So how it will look like? So spherical mirror, if you turn to the front, it will be like this. So the diameter of this you have to take. So this is the diameter of the spherical mirror. So this distance is called as aperture. So this is called as aperture. So is this clear? So these are the components you need to learn. So using this we are going to draw the ray diagram. It will become very simple. So you need to know the components along with the definition. So students, if you are new to our channel, subscribe our channel, and also if you have any doubts you leave in the comment section. I'll meet you in the next video, students.